Hi, my name is Vladimir Alexiev and I'm OntoText Chief Data Architect. Miroslav Chervensky, who is the OntoText Platform Product Manager, also contributed to this presentation. And today we'll talk about industrial data standards and exploring them using the OntoText platform. So we'll talk about the Industry 4.0 Knowledge Graph by Fraunhofer. And these are the most important links related to this presentation. So the presentation itself is at this URL. You can browse it at your own pace. The main entry point of Industry 4.0 KG is this URL. This is the OnText platform documentation. And we'll shortly put up the platform test instance for you to be able to try the GraphQL queries that we'll discuss later on. These, by the way, are all my publications. So industry standards obviously have been crucially important for the industrial society because they enable interoperation and collaboration. In addition to traditional industrial standards, there is now a whole bunch of new and upcoming standards for Industry 4.0 or digitization, for things like digital twins, industrial IoT, digital asset management, etc. The standards landscape is large, and so the question is how can one understand it or get an overview? And for this, I think that the classification frameworks proposed are very useful. There's a number of them, for example, one by the US NIST, there's another one by the Industrial Internet Consortium, and there's two more recent one by the German platform Industry 4.0 initiative. One is called RAMI, Reference Architectural Model for Industry 4.0, and the other one is the Asset Administration Shell. In particular, the Asset Admin Shell is not just a classification, but is also designed for how you can use a bunch of standards together using semantic technologies to tie them up. The Industry 4.0 KG describes about 320 standards together with their classifications, purpose, relations, and so on. This is the documentation of the ontology that was designed to hold this data. This is the main entry point and visualization of this dataset. There's extra visualizations in this link, is described in this paper, and it integrates classifications according to a number of initiatives. Like I mentioned on the previous slide 4, but there is more than that. This is the main visualization of I40KG. So it puts in the middle RAMI at the admin shell, and then it describes various concerns or topics and how different standards address these concerns. So for example, for communication, one of the main standards that is pointed out is the OPC UA, which is a standard for machine-to-machine communication. You can click here to get a full version of this image. One of the very useful visualizations that I like about I40KG is this that I call progressive zoom into classifications. So at top level, you see the 15 or so classification initiatives that are covered by this knowledge graph: RAMI, NIST, IIRA, the admin shell, and some small ones. If you click on one of them, you see the different areas of that classification. So for example, for NIST, you have modeling, product model data exchange, product lifecycle management. And if you click on one of the areas, you see the standards that are placed in that area. This knowledge graph has information about something like 160 concerns or different areas or topics that are relevant to industry digitization. For example, artificial intelligence, and there's a link which says it supports data analytics. So it's not just a nomenclature, but there's also some links between them. Okay, if we want to use this data, the first thing that we need to do is to figure out what is the data model or how is the data laid out in it. And the publication shows this data model. So you have standards, you have standards organization. Standards are classified according to these modern classifications, as well as the more traditional international classification for standards, or ICS. But this picture is quite idealized. If you look at the full complement of data, you see a whole bunch of relations. So here I have depicted property instances that connect at least 5 nodes of the same class. So every here node is a class, every link is a property, and every link depicts at least 5. There's 78 such links. If you look at the full variety of properties, you will find over 300 rows with smaller cardinality than 5. In order to simplify the exploration of this knowledge graph, we use the OnText platform, which is it comprises a number of enterprise services like role-based access control, monitoring, provisioning, but most importantly, it includes GraphQL querying of RDF knowledge graphs. GraphQL is this quite modern language for putting simplified facades over storages or other data services, and it's a very easy way to build backends as a service. It's very popular with modern full stack developers, especially the ones working in JavaScript and TypeScript. So before we can use the platform, we need to create a semantic object schema for the RDF data. And first we used the AL2SOML generator. So it takes any number of RDF ontologies, RDFS or AL, combines them and generates a SOML schema out of them. We use this wizard from the OnText platform workbench. After we generated the schema, then I made a number of fixes or additions to the schema. For example, this here config says that the default language for fetching strings should be first English and then any language tag or no language tag at all. And the reason is that within the I40KG, they have the tag English on every string. I guess this supposes further internationalization of that knowledge graph. In order not to have to specify the language English for every query, we specified it once for the whole schema like that. Another simplification is that whenever possible, I have removed prefixes of properties. So in GraphQL, we're just gonna fetch a property like that instead of having to specify the prefix, and some other additions. Okay, so now we're ready to run the first query against our semantic representation of the knowledge graph. In this case, we're saying, give me standards that, first of all, have an ICS classification. This is the more traditional international classification of standards, and also the more modern CAS classification. Fetch the ICS, fetch the classification, fetch the publisher, and fetch two extra things about the classifications. Where is it described and what is it associated with? And it turns out that there's only one standard that has all of these outgoing links. Here's the result in just presented in a more compact way. So we see that IEC 60839 is classified in the area of alarms and warning systems. It's also classified within the RAMIAs, a standard about control devices, field devices, and so on. And within the administration shell, it's classified under the topic of security. This topic security is related to those other topics of trust, privacy, and security by the Big Data Value Association, the Data Transfer Project, and the FIWARE European Research Program on Future Internet. So it seems that the classification is correct because this standard is about alarms. And this gives you links between different classifications by different organizations. The next query, we're looking at licenses of entities, and it turns out that there's about 70 standards for which the license is known. In addition to the data, we get an error, which is not fatal. It just says that there is one particular license with one particular standard with two licenses, dual licensed. Now, I assumed that every standard has only one license, which turns out to be not 100% correct. And I removed this declaration that says this is a multi-valued property, or the maximum number of entries is infinity, because it is less expensive to query for single-valued properties. The next query we'll show is about this ISO 15926 standard, which is touted to be the lingua franca of semantic global interoperability. And if we run this query, which looks for the classifications of the standard and related standards, we'll see that it is pretty well connected. It's related to about 30 other standards. And let's look at the first two. One is the OPC Unified Architecture, which is the standard for machine-to-machine communication. Another is this German standard that combines OPC UA with automation ML. One problem, however, with ISO 15926 is its complexity. So you see here this very complex diagram that shows how you express that a certain property of a design individual must lie within a certain range. Let's say the operating temperature of a pump is between -10 degrees and +40 degrees. It takes about 23 nodes, all of this here, and about 100 triples to express this relatively simple fact. And whereas these templates allow you to produce the triples relatively easily, they do not make the querying easier. Unless you query for the template node, this NRE relation here, and then this begs the question, why did I need to expand all of these triples anyway? The final query that we can look at is this here. So we're looking at concerns and their IDs and labels. And remember, concern is a topic that is relevant to industry data standards.